Can I go? All right. Thanks very much for putting the paper on program. This is joint work with Felipe from Duke and Chao from CUHK. All three of us are here today, and obviously I lost the lottery, so I'm going to be the presenter. So the research question of this paper is how do firms manage their debt maturity as the fundamentals value of the firm varies over time. So you could imagine this is an old and classic question, so there must be a lot of research on it. So we're going to hopefully bring in some new insights in this model. So in general, if you want to answer a question like this, you need a model with at least two features. First of all, you need a model with shocks to firms' fundamental value over time, and second, you need the firm to have flexibilities in issuing debt of different maturities. In our view, the literature does not exactly have a model like this yet, and this is where hopefully our paper can make a contribution. So we're going to build a dynamic capital structure model with two regimes. There's upturn, there's a downturn, and firms in our model are going to have two types of shocks. There are frequent small shocks, which we model as Brownian motion. There's also infrequent large shocks, which we model as regime shift, okay? And really a distinguishing feature of our model is we allow firms to continuously issue long-term and short-term debt, and this issuance is with full flexibility. In other words, we don't put restrictions such that firms can only issue debt under some conditions, such as buying back all the existing debt. Okay, so our model is fully tractable, and we're going to deliver some readouts. And first of all, we're going to show, we're going to describe how debt is issued in different states of the world. So first, what we show is if there's no large shock, if there's no regime shift, if there's only small frequent shocks, what's going to happen is the firm only issues short-term debt. In other words, the only reason that the firm might issue long-term debt is because the firm is concerned with the large shock and hopefully to hedge against that using long-term debt, okay? And in the model with large shocks, what we show is the firm only issues long-term debt under two conditions. One, the firm is in an upturn, and number two, the firm does not default immediately if all of a sudden downturn arises, okay? And we're going to show these are the situations where long-term debt can offer some hedging benefits which are valuable to the firm. So essentially our model, our theory of debt maturity is a choice between dilution and hedging, and these are the trade-offs we're trying to highlight. So on one hand, long-term debt can be diluted in the sense that after the debt is issued, the borrower can issue more debt in the future and dilute the existing debt, okay? So this is, the force has been mentioned very early on, and more recently it has been formalized in two papers by Peter and the co-authors. So what we're bringing here is when the firm issues short-term debt, and this short-term debt perfectly resolve the dilution problem because for short-term debt, it matures before the borrower gets a chance to issue again and gets the chance to dilute it. So in other words, short-term debt does not suffer from dilution, and this implies if dilution is the only concern of the firm, then it should exclusively issue short-term debt. On the other hand, we're going to argue that long-term debt offers some hedging benefits against large shocks. In particular, we're going to focus on negative shocks where the regime can shift from an upturn to a downturn. So the idea here is for any debt, there is an embedded default option value, and after the downturn arises, the default option for short-term debt expires immediately. The borrower needs to pay short-term debt immediately, whereas long-term debt default option expires in the future. And because of this, expiration date in the future, long-term debt essentially postpones the default and allows the borrower to have some time to recover after a regime shift. And this is very, very valuable in upturn. This offers the hedging benefit. All right, so on top of these readouts on debt issuance, we're also going to show some unique empirical implications. For example, we have some unique findings, unique predictions on how cross-sectional and time series we should observe in debt issuance. And our model implies that for empirical research in debt maturity, there is a need to differentiate the maturity of outstanding debt, the stock, versus the maturity of newly issued debt, the flow, and there's a difference between these two in certain states of the world. And finally, we're going to classify default from default into more gradual default and more sudden default. And we're going to show that gradual default is more driven by too much long-term debt, whereas sudden default is driven by too much short-term debt. All right. So without further ado, let me jump into the model. So we're going to have a risk-neutral borrower. Sometimes we call this guy equity holder. This guy is risk-neutral. He has discount rate rho. The underlying cash flow follows a two-stage geometric Brownian motion process. So here, xt is the level of the cash flow, and mu theta is the regime, which stands for the expected growth rate of the cash flow. dbt is the Brownian increment. So here, mu theta could be either mu low or mu high. Mu low is less than mu high, and we call it either a downturn or an upturn. For today's talk, we're going to assume that the firm starts in an upturn. So at time 0, it's an upturn. And then, following some Poisson shock with rival rate lambda, it's going to enter into the downturn and stays there forever. Okay? In other words, we're going to assume the states are absorbing. And in the paper, we discuss the situation when states are more transitory, and our results go through. So the borrower is going to choose to endogenously default at some time tau b. All right, this is going to be an endogenous choice. And we assume when the borrower default, the recovery value is 0. In other words, bankruptcy cost is 100%. So this assumption, we're taking this to extreme because we want to rule out issues of dilution in bankruptcy. We want to rule out different debt with different seniority. This implies seniority is completely irrelevant. Really, we're going to focus on dilution outside the bankruptcy. The final group of agents in the model are competitive risk-neutral creditors. So they have discount rate R, which is less than rho, which is the discount rate of the borrower. So in other words, we assume creditors have lower funding cost, which is the reason why the borrower wants to issue debt in the first place. In the paper, we also consider tax shields, and there are some very nuanced differences, which I'm going to skip. So the borrower is allowed to issue two types of debt. Short-term debt matures instantaneously. So we're going to use this notation, dt minus, to represent the amount of short-term debt mature at time t, and creditors they need to be compensated with credit risk. So yt minus will be the short-term interest rate just to compensate short-term debt. So here yt minus is basically r plus the hazard rate of default between a very short period of time. So when default happens between t minus dt and t. The second type of debt we assume is long-term debt. This is more standard. At any point of time, we're going to use ft to represent the amount of outstanding long-term debt. It has coupon rate r. It matures at some exponential rate c, and the price of the long-term debt includes coupon payments, which and also principal payments. So coupons are received as long as the debt has not matured at tau c. Or as long as the firm has not defaulted at tau b, whereas principal is received as long as the firm has not defaulted before the debt matures. So within a short period of time, if you think about the net cash flows to the borrower, there is xt, the cash flow generated from the asset. There's payments, both coupon and principal payments to long-term debt, r plus c times ft. There's also interest payments to short-term debt. And in the second line, this is the focus of the paper, we're going to have the proceeds from debt issuance. So PT is the price of long-term debt, and DGT is the amount of newly issued long-term debt. And finally, DDT is newly issued short-term debt. Okay, so the borrower's problem is choose when to default, and at any point of time, how much long-term debt to issue, how much short-term debt to issue. And the objective function is to maximize the discounted net discounted net cash flow until the firm defaults. So I want to emphasize that these decisions, default, debt issuance, they are made at every point of time. There's no pre-commitment to a path going forward, so, right? We're going to focus on the Markov perfect equilibrium. There are 4 state variables. Theta t and xt describe the regime of the firm and the level of the cash flow. Ft and dt describe the amount of outstanding long-term debt and short-term debt. We're going to follow the literature by restricting to a so-called smooth equilibrium, which says there's no jump in long-term debt issuance. In other words, at any point of time, the issuance rate, the issuance of long-term debt follows a finite rate. So we're going to rewrite this dgt as little gt times ft times ct. So going forward, I'm going to sometimes call this little gt as the issuance function of long-term debt. Let us also define this big JT as the joint value of equity holders and short-term creditors. So the first result of this paper is really that even though equity holders make debt issuance decisions, these decisions are made to maximize the joint value of equity holders and short-term creditors. Okay, so the decisions are made to maximize JT. And the reason is because these issuance decisions will affect how much profits that the borrowers can receive from issuing new debt. Okay? And from the borrower's perspective, she does not care how the issuance decisions affect existing long-term debt. She really cares about the value of the equity plus the value plus the process of newly issued debt. And in a smooth equilibrium, the newly issued long-term debt is very small, and in continuous time is approximately 0. So really, the goal is to maximize equity value plus newly short-term debt. So this result implies that when we study debt issuance policies, we can treat equity and short-term debt as one entity. And it also implies we can eliminate short-term debt dt as one of the state variables. Okay. We're also going to take advantage of the scalability of the problem. We're going to scale the value function big J by x, the level of the cash flow. We're also going to scale the long-term debt D, short-term debt D by x as well. So we're going to use little j as the value function going forward. We're going to use little d as the amount of short-term debt going forward. So in the end, the model has 2 state variables. There's theta, which stands for upturn, downturn, and there's little f, which is long-term debt scaled by cash flow. So these are the 2 state variables we're going to use for the rest of the talk. Let me jump into the equilibrium. Before getting into the details, I just want to give a very quick review, a brief preview about what you should expect in equilibrium. So we are going to focus on the situation that downturns is sufficiently bad and also sufficiently likely. So in the upturn, the firm is worried, so the firm wants to hedge against a downturn. So here's a preview of the issuance policy. In a downturn, each axis stands for a different level of long-term debt. In a downturn, regardless of the level of long-term debt, what's going to happen is the firm will only issue short-term debt. Okay? Whereas in the upturn, there's a very crucial threshold, and what's going to happen is when long-term debt F is above this threshold, once again there's no long-term debt issuance, but instead the firm will issue risky short-term debt. Okay, so the firm will issue risky short-term debt. When F long-term debt falls below this threshold, the firm will issue riskless short-term debt, and the firm will issue some long-term debt. Okay, so long-term debt is only issued in upturn and when the existing level of long-term debt is sufficiently low. All right, so with that, let me get into the details. So I want to first highlight a problem of long-term debt, which is dilution. So let's start with a simpler model where there's only long-term debt, there's no short-term debt. And I want to convince you that in this situation, the borrower always has incentives to dilute existing long-term creditors. Why is that? let's think about the following thought experiments. Suppose the borrower is initially unlevered, there's no debt at all, and the borrower says, look, going forward, I am going to commit that I will never issue long-term debt, and in such a situation, the firm will always stay unlevered, there's no leverage, and the firm will never default. And this immediately implies that for the marginal unit of long-term debt, it's riskless. When it's riskless, the price of the long-term debt is going to be 1. But then from the borrower's perspective, because the borrower is more patient, and she's going to value the marginal unit of long-term debt at some level less than 1, and that implies the borrower wants to sell the debt, wants to issue. So in other words, when the borrower says, look, I am not going to issue going forward, such a commitment is time inconsistent. In fact, the borrower does want to issue, and when the borrower issues, this is going to dilute long-term debt, okay? And in general, this thought experiment holds even for a levered borrower. So in equilibrium, creditors, they expect that when they offer long-term debt today, in the future, they will be diluted, so they're going to charge a higher spread and a lower, and the price of the long-term debt is going to fall. So, because of this dilution problem, long-term debt is very costly because creditors anticipate they will be diluted, price will be low, credit spread is high, and also because of this dilution problem, when the firm has a negative small shock, even though the firm should reduce leverage, instead of reducing leverage, the firm actually increased leverage because it can dilute and pass on this to long-term existing creditors. And this is related to the leverage ratchet effect developed by Anat and also Peter in an earlier paper. So in the meantime, for short-term debt, it's cheap because short-term debt does not suffer from dilution, because all the short-term debt, they are repaid before the borrower gets to issue again, okay? And for the same reason, after a small and negative shock, short-term creditor says you have to reduce leverage, at least you have to reduce the amount of short-term debt borrowing, and that's also beneficial to the firm. So, and remember, in the model, in the upturn, we only have these small frequent Brownian shocks, and that implies there's nothing about hedging. So, so that's why in a downturn, everywhere the borrower is going to issue short-term debt, and it never issues long-term debt. Okay. So now let me turn to the upturn. Just to remind you, we have two types of shocks. There's the Brownian motion, which stands for small shocks, and there's also the regime shift shock, which all of a sudden the regime can shift from an upturn to a downturn. So when such a regime shift occurs, the borrower has already taken some amount of short-term debt, which is DH, and going forward, the maximized value of the borrower and short-term creditors is at most JL. So obviously when DH is above JL, the borrower says, well, I'm just going to default, okay? So when a downturn arrives, the borrower will default if DH is above JL, and that implies that the choice of short-term debt in the upturn is going to evolve some trade-off which is very similar to the standard capital structure theory in trade-off theory in capital structure. On one hand, the borrower can choose to issue a riskless amount of short-term debt, which is JL. In this case, there's no default even after the downturn, and this is going to bring in some flow benefit, rho minus R times JL. On the other hand, the borrower can choose to issue a higher amount of short-term debt JH, but this is going to lead to default. It brings a higher flow benefit, but in the meantime, it's going to bring to default when the downturn arrives. This is, you can think about this as this bankruptcy cost. And just to make a note, quick note, any choice of short-term debt between JL and the JH can never be optimal because it's going to lead to the same bankruptcy cost, but comes with lower leverage benefit. So in this graph, we are showing the additional bankruptcy cost in green and the benefits from additional leverage in blue. So here you can see there is a threshold here, FDEC. When F is above FDEC, the additional bankruptcy costs falls below the additional benefit of leverage. Intuitively, this is because when F gets very high, the firm is very close to default boundary, even in the low states, so the additional bankruptcy cost becomes very low. So just to summarize our short-term debt issuance, in equilibrium, when F is below FDEC, the borrower will issue riskless short-term debt, and when F is above FDEC, the borrower will issue risky short-term debt. Before getting into long-term debt, I want to highlight the role of hedging and the role of default option in general. So if you think about the regime shift, we can take a snapshot at the balance sheet of the firm. So before the state transition, the cash flow grows at a very high rate μh, and after the state transition, the regime shift, the cash flow is going to grow at a lower rate. So all of a sudden, the asset value is going to shrink. But after the transition, the firm still needs to pay back the same amount of short-term debt D, whereas the market value of long-term debt will have a discontinuous drop from PH to PL. So if we think about the value of debt, we can always rewrite the value of the debt as the difference between the discounted value of all the riskless payment subtracting the default option. So after the transition, when the price of the debt drops, it implies the value of the default option goes up. And moreover, and what's more important is if we compare long-term debt with short-term debt, long-term debt is associated with a higher value of default option because the borrower can further postpone default with long-term debt. So in other words, when the downturn arises, short-term creditor says, you owe me this much, you have to pay immediately. So the default option of short-term debt expires immediately after the downturn arrives, and the value of the default option is unchanged, whereas when the downturn arrives, the long-term debt default option does not expire immediately. Instead, it expires in the future. So the option value goes up, the price of the long-term debt goes down. And because of this, long-term debt allows the borrower to not immediately default, but allows some time to postpone default and even to recover. And by doing that, long-term debt allows the borrower to postpone default and offer some hedge against this regime shift, even in the upturn. Okay, so this is what the equilibrium long-term debt issuance looks like. You can see there's FDEC here. When F is above FDEC, we're going to show you there's no need to hedge. Why is that? Remember, when F is above FDEC in equilibrium, the borrower will issue risky short-term debt. What this means is after the regime shift, the borrower will default. So default will occur immediately after the downturn arrives. In this case, there is no reason for the borrower to hedge the downturn, and there's no need to issue long-term debt. On the other hand, for F less than FDEC, okay, we do see some issuance of long-term debt. In this situation, after the same regime shift, the firm continues, there's no default, there's no immediate default, and long-term debt allows the borrower to further postpone default, and this is very valuable. This offers hedging against the downturn, so even in the upturn, the borrower wants to issue that, okay? So this is the same graph I showed you earlier on. Just to summarize, basically, there's no long-term debt issuance in the downturn. There's no long-term debt issuance in the upturn when there's already a lot of long-term debt and it's very close to default boundary. And really, the borrower only issues long-term debt in the upturn when the amount of short-term debt is riskless. There's no immediate default after the regime shift. In fact, we can decompose the equilibrium long-term debt issuance policy into different components. So here, the numerator term rho minus R captures the benefit of leverage. PH minus PL reflects the change in the debt price, which also reflects the change in the default option value of the long-term debt, which captures the hedging benefit. And finally, the denominator term captures the price impact from long-term debt issuance, right? I want to point out some very unique empirical implications from our model. First of all, we want to highlight that there's a distinction between outstanding debt versus newly issued debt. With a static model, more or less, you get the same prediction. In our model, for example, if you go back to this regime when in Upturn, and there's already a lot of long-term debt, in this situation, for newly issued debt, it's exclusively short-term. In other words, if there's already too much long-term debt, that can push the borrower close to default or in distress. But in this situation, if you look at newly issued debt, it's going to be exclusively or more or less short-term, all right? And moreover, if you think about default in our model, there are two situations. The first type of default occurs when F gets all the way to default boundary, and this is because there's too much long-term debt, there's excessive amount of long-term debt relative to the deteriorating cash flow, so this default is more gradual and to some extent anticipated. Whereas another type of default in the model happens when regime shift from an upturn to the downturn. In this case, default is more sudden, it's less anticipated, and it's triggered by a large shock and too much short-term debt taken before the large shock happens, okay? I want to talk some more about the cross-sectional. So if you want to think about large shocks as those being more systematic, being harder to diversify, then our model implies that for firms that are more exposed to large shocks, you can think about these as firms with higher asset beta. For these guys, they're going to use more long-term debt in their capital structure. This is something we feel interesting and can potentially be tested in the future. And finally, in terms of the time series implications, our model implies pro-cyclical maturity when the firm is in the upturn, then the maturity expands, whereas when the firm is in the downturn, the maturity gets shortened. But what's interesting is if you think about the firm within a regime, okay? When the firm is within a regime, if there's a small negative shock, this is going to force the firm to reduce short-term debt. In other words, within a regime, cash flow and maturity co-move negatively with each other, whereas if you think about this comparison across the regime, cash flows and maturity tend to move in the same direction. All right, that's basically what we have. So in this paper, what we do is we have a model. It's fully tractable. we can study debt maturity choice and their time-varying fundamentals with two types of shocks. We have the borrower with full flexibility in issuing two types of debt. And the key trade-off we want to take away is maturity choice is a trade-off between dilution versus hedging. And finally, our model highlights that short-term debt and long-term debt have different roles in the capital structure. Short-term debt does not suffer from dilution and to some extent force the borrower to reduce leverage after bad shocks, whereas for long-term debt, it offers hedging and it can allow the borrower to postpone default and allow some time to recover. And this is very valuable before the downturn arrives, all right? So this is all I have. Thank you very much for your time, and I look forward to Peter's discussion.